All right. Chapter 19, one chapter, all about partitioning and file systems and RAID and LVM. We were talking about this stuff just a little bit last week. And so, just wanted to be sure that everybody recalls some of that so we can move on. So I'll go through some of the stuff that we already know pretty quickly. Partition, right? Just a small portion of a disk that you may have chopped up. You can check these things on any given machine. If you do something like DF, you can see all of the partitions that are mounted on any given system, or you can use LSBLK to show you all of the partitions here and where they are mounted. And Ubuntu actually does it the most simple. They typically just give you one. They mount the big partition on root, and that's pretty much it. The reason this is typically it'll put swap on the other partition, but Ubuntu has gotten away from doing swap partitions and now have swap files. So, there we go. CentOS is similar. So if you do DFH, you'll get those same partitions. Almost. Do LSBLK and you'll find even more. But notice that these things are a little bit different. Oh, here we go. These things are a little bit different. You have your root, which is mounted at root. You have swap, which is mounted as swap. But the way that it is, slightly different, right? I mean, you have this tree under SDA. You have SDA1, SDA2. Those are typical normal partitions. But underneath SDA2, you have these additional breakdowns. If you look at Ubuntu, they are not there. You just have SDA2, and that is directly mounted at root. In CentOS, SDA2 has two sub-partitions, essentially. And they're really not partitions at all. They are volumes. So LVM, being the logical volume manager, which we'll talk about here in just a little bit, I just want you to see what it looks like and that it exists, is basically a way to take one partition and chop it up into whatever you want it to be. It's a logical partitioning of a drive, but they're not partitions in the normal sense, right? They are just segregations of a piece of a hard drive that LVM has been given. Partitions actually are written to either the MBR, so master boot record, we talked about that in the operating systems class, or GPT, the GUID partition table. So either or, you are writing it to some part of the hard disk so that you are able to access that anywhere on any operating system, whether you take it out of this computer and move it to the next, something like that, right? The partition table moves along with it. LVM, while you can still get that information from different computers, LVM is stored in the operating system itself, or in the actual disk itself. And the way that you would look at it is something like LV sudo LV display. I think I spelled that right. Yeah, and you can get some information on, I'll go ahead and capture that. You can get some information on the swap partition. It's labeled swap. The volume group is CL. And if you look up, you can see CL swap. And then if we go down, you'll see CL root as well. And it'll give you the same information that it had, right? It's about 17 gigs in the volume group CL, named root. And we'll get into that here a little bit more as we go along. And then with OpenSUSE, you've got a similar situation, but it's even more complex. OpenSUSE has this thing called subdivisions. Now, this is not anything that you're going to need to know for the test. This is just the way that OpenSUSE puts it together. For all intents and purposes, you can kind of ignore it. But I want you to know that it exists. So DFH, you can see, notice SDA2, 2, all the way down. And it's mounting each of these individual things here. This way, you get those logical breakups, and you are able to take those and mount them elsewhere after the fact way easier than otherwise. So if we do an LSBLK, you'll still see the simple stuff, SDA1, SDA2, SDA3. And then if we do, I don't know that any of that is LVM. So sudo lv display, we'll see that. And it's not the case. So nothing under LVM. These are just actual partitions on the disk, and they just happen to be mounted all over the place. So now that you know how to look at partitions, right? DFH to see what's mounted, get some information on it. LSBLK to find the actual block device information. And if you happen to be using LVM, you can do LV display to see each of the volumes that you have on your system, where they're mounted, and some basic information about them. So that's the deal, right? Those are partitions. You get to see them in action. fdisk. This is a utility typically used to create partitions. Now, we're going to talk about fdisk a little bit more down here. It's one of those things that there are caveats because of kind of when we are. I guess the current situation of Linux at the moment, which is not really that difficult, just stuff has not caught up with the times in terms of people talking about it. So anyway, if you have a disk, you create or you install a new disk onto a system, and you just want to be able to like format the entire thing, use it as one entire disk, and be able to put stuff on it or something like that, then fdisk is going to be the way that you want to do that, and I'll actually show you how to do that here in just a sec. So once you create stuff with fdisk, you probably want to reboot. That way it has all of the information about the disk. If you are setting it up to boot or load up on boot or something like that, then that will be obviously after a boot. So you also need to be familiar with the fstab file that lives in etc. That file will contain all of the information about all of the volumes that you want to load up on boot. So let's take a look at that real quick. So the Ubuntu one will be pretty simple. I like to start with the Ubuntu stuff just because it's simple, and that way we can build on that as we move on. So fstab. If you take a look, remember that in configuration files like this, every line that starts with a hash mark is ignored. Those are comments, right? So it's just giving you some information about it, giving you some ideas as to how this stuff is actually put together, right? So there are 6 options that fstab wants you to know. And you can see this one is set by UUID. So UUID is a unique identifier for every partition on the system. The way that you find that is BLK ID. So block device ID. You do that, and you can see dev SDA2, right? Second partition on the disk, identified by that UUID. And if you notice, it's the same exact UUID up here. Tells some information, partition UUID. Then, so this UUID right here needs to be mounted here at root. It is ext4. I want the default options. It is not being dumped, and fdisk will ignore it. So, how do I know all that, right? That right there. So file system, identified by the UUID. Mount point, root. Type is ext4. Options, set to the defaults. Dump, 0 means no. So do not dump it. And dump is another way, it's a really old way of saying backup. Pass, as in, how do you want fdisk to pass this? How many passes, or I'm sorry, in what order do you want fdisk to deal with this? So if it's 1, then it'll be the first thing that fdisk looks at. I'm sorry, not fdisk. Wow, I'm drawing a blank. The thing that scans the FSCK. There you go. FSCK. So in what order do you want FSCK to deal with this disk? And typically, if you're talking about a disk that is root, you want that one to be first. So if you were going to let fdisk scan this thing for errors or something like that, then you would stick a 1 there. Any other partition, you would want to stick, 2, 3, 4, 5, 6, 7, 8, 9, 10. however many disks you have, you want to put them in order. And that's only if you want error checking on it. If you actually want FSCK. Wow, well, I just drew a blank again. FSCK to be looking at that disk in the first place. So we'll talk about more of these things, but these are they're coming up, so I want you to see them. Anyway, and then here's a swap image. You can see what I was talking about. This is not a partition at all. It's a file named swap.image in the root of the file system. And then you can see there isn't a mount point because it's swap. It is swap. Option is turn it into swap. Use it as swap, SW. Do not dump it or back it up, and do not check it for errors. So that's basically how you read that file. One of the cool things about this stuff is that it doesn't matter if you tab it or space it. As long as there is a delimiter of one of those two things between each of these options, it'll work. It'll work. So if you notice, there's just one space, right? Space, 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 space. Not a tab or anything like that. But these, if you double click here, it'll select all of it. That is a tab. So swap image tab, none, tab, swap, tab, SW, tab, 0, tab, 0. And here, same thing, UUID, but space. Root of the file system, space, ext4, space, default, space, 0, space, 0. So doesn't matter. Spaces or tabs, either or. And this goes across CentOS, OpenSUSE, Ubuntu, all of them. They all deal with it like this. So this is how you automatically boot them. If you make a mistake in fstab, it will tell you by not booting. That is the deal. So be aware that if you are messing with fstab, you reboot, and then it drops you into the recovery mode. You have made a typo in fstab. Here's the thing about fstab, as with any other configuration file. Make small changes at a time. If you got 7 partitions to mount, do them one at a time. Reason I want you to do that is it is way easier to figure out where you made a mistake if you're only doing one change at a time. Right? You get to the 4th partition, you reboot it, and then it crashes. It's way easy to figure it out, right? Like, you know you need to be looking at that 4th partition line if that's when it stopped booting. Versus, you put all 7 partitions in, you reboot, and it's like, which of these partitions is broken? And then you have to do exactly what I'm talking about. You have to start working your way backwards and correcting your mistakes backwards, but now you're dealing with 7 things instead of 1. So slowly. Let me check on this real quick. Okay. We'll look at that again in a minute. Anyway, so that's it, right? So the fstab stuff I was talking about, there it is, defined for you right there. Spaces or tabs, either or. Here's what it looks like in Ubuntu. Here's what it looks like in CentOS. Right? They're doing it with devmapper CL root because they're using LVM, and LVM partitions are stored here instead of like dev SDA2. They're stored in devmapper. CL is the volume group. Root is the logical volume name. We'll get into that a little bit more as we start talking about LVM. Just so you know. And then the rest of this is the same, right? So mount that at root. It is XFS. And this is one of the things that you need to know. You need to know what file system type they are. If you do not, you'll put it in fstab and it'll be wrong, and it won't mount properly, and obviously will not boot. So be aware that if you're creating these, the ones that are already created are already in fstab for you, so you don't have to worry about those. But any new ones that you create, you'll have to take note of the file system that you have in there, otherwise it will be wrong, right? Notice ext4 up here, xfs here, btrfs down here. It matters, so make sure you have it right. Defaults here, 0, 0, so no dumping and no checking. UUID of this, mounted at boot, it's ext4, set to defaults. Now here we go. It is dumped and will be the second disk to be checked. Now this is to make room for checking root if you turn that on. Now if it's the only one in the list, even though it's second, it'll be the first one to be checked because there's nothing being checked before it. There is no first disk to be checked. So this one will still get checked first. And you probably do want to check boot every now and then. And then obviously your swap here, swap there, set the defaults. Unlike Ubuntu, which is setting it to swap, defaults is fine. and 0, 0. Don't back it up and don't check it. Now Btrfs, or I'm sorry, OpenSUSE, same kind of deal. But if you notice, look at these UUIDs. These are subvolumes. They're set up a little bit differently. And basically what you want, what you're doing here is just making the location here, setting it up in FSTab. So all you got to do is come in and actually just edit this, right? Edit the UUID that you want in here. And then everything else is taken care of. You'll probably want to change this subvolume to default to something like that if you're putting it onto a different disk or something. We're not going to be dealing with that, so don't worry too much about it. But it is there, and it'll raise questions if you're really astute. So anyhow, these are subvolumes. Don't worry too much about them. It's just another technique to actually mount disks, and they are way out of the scope of this particular test anyway. So if your file systems are not mounted automatically at boot, but you want to mount them, how do you do that? With the mount command. So whether that is logical volumes like in-dev mapper, or actual physical partitions through MBR or GPT, whatever the deal may be, you can mount them like this. Mount what, where. So mount the command, what. I want to mount this partition that answers the what. And then mount it where? Right here, Media Leo stuff. That will, as long as dev SDB2 exists and is a valid partition, that will work just fine. And it will mount in Media Leo stuff. So if I do CD Media Leo stuff, I'll be able to go directly into that disk. So since we're getting into this, I'll go ahead and bring something in. If I can find it. All right, and y'all will be doing this. Y'all will be adding storage into VMs. So kind of keep an eye here. Oop, not add, create. I want to create. Continue on, continue on. 10 gigs is fine for most applications. There it is there. Choose it. Cool. Start this guy back up again. And you'll see what I'm talking about. So we were talking about FDisk. We were talking about mounting. We're talking about FSTab, all this kind of fun stuff. So I wanted to show you how exactly to use all those things as well. So as that's booting, we'll go through the rest of this stuff. We'll come back around, and I'll show you all of this stuff. So make swap. Let me see. Oh, let me finish up. So you can mount that stuff, right? So dev SDB2, mount that here. To unmount it, once you're done, you will use the umount command on either bit, on the dev SDB2 bit or on the Media Leo stuff bit. It does not matter. If you say umount dev SDB2, it's the same as saying umount Media Leo stuff, and that will unmount things. Pay attention here. See where that cursor is? There is no in. That is not unmount. Do not type unmount. It will not work. It is umount. Be aware. I've had so many people hit their head on the desk because of something like that. That is not a typo. It is umount. Anyway, swap partitions. They're pretty simple to do. All you really got to do is create a partition with fdisk. Then run make swap on it. So make swap dev SDB3, something like that. If that's what swap is, right? That's to turn it into a swap partition, and then swap on. You'll want to do swap on space dev SDB3. If you want to turn it off, swap off dev SDB3. And if you want it to mount every single time, do it in etc FSTab. So make it look like this last one, except it should be dev SDB3 if you're doing a disk partition, but everything else can stay the same. Or you can do it here, same here as in CentOS if it's LVM, and you can just use defaults. That'll work just fine. All right. So here's the thing. This is what I was warning you guys about a little while ago. For the exam, here's what you need to know right here. I don't know why. Fdisk has known how to do pretty much everything for the entire time as this book was being written, so I don't know why exactly this information is there, and I don't know exactly why the test still has really old information. But I'm going to tell you what is going to show up on the test. If you are dealing with GPT, the GUID partition table, instead of master boot record, you will need to be using gdisk. gdisk is just like fdisk, but it deals with GPT. fdisk is for MBR, master boot record. So fdisk for MBR, gdisk for GPT. Now here's the truth. That was what you needed to know for the test. Here's what you need to know for practicality's sake. fdisk does it all. Do not bother with gdisk when you're playing around with partitions. It is, at the risk of being too blunt, it's pointless. All of the gdisk stuff has been merged into fdisk, so fdisk can handle all of it. There really isn't much of a use using gdisk. Parted, though, is kind of a terminal-based, terminal GUI, text-based UI, where you can use the arrows to kind of move around or whatever, and mark things as partitions, things like that. And there's actually a graphical one, too, called Gparted, which is really kind of interesting. It's pretty cool. It's like, Gparted actually looks like, what is the name of that thing? Wow. See, I haven't been on Windows in like a week, and now I've already forgotten. Disk management. Looks a lot like disk management. So if you're interested in doing things from a graphical interface, Gparted will work for you just fine. Works just like disk management. Parted, though, is the text-based version of it. And it does exactly the same thing as fdisk does. So this is kind of a preference thing. If you want to deal with fdisk, deal with fdisk. If you want to deal with parted, deal with parted. It doesn't really matter. And the idea, after you create partitions, is to make a file system on it. So this will go to, this goes with parted or fdisk or gdisk. After you are done creating your partitions, you want to make fs, whatever file system you want it to be. You want to mount it, just to be sure that everything works. You have the syntax right. And then you want to update the etc fstab file so that they mount automatically every time you boot. Okay, so here's what we're going to do. We're going to go backwards a little bit. We're going to look at some of these things. We're going to look at fdisk and just kind of the basic idea of how to do all this stuff. So I don't have it formatted, so none of it is in the right font. But if you want to see the process, this is it. This is basic fdisk, creating your partitions, then making your file system, then mounting it, then making sure you have the correct permissions on it, and also at the end of this, making a swap file or a swap partition. So this is your cheat sheet down here. If you forget, because not saying that you necessarily will, just that there's a lot to remember, right? Windows just holds your hand and makes you think that it's like all green grass and meadows, and it's not. There's actually a lot to this. And especially when you want something a little more custom, or you want something that is right only for you, then you're going to want to know how to deal with all of this stuff. And Windows can get that complex. They just tend to hide stuff from you. So I'm going to show you how all this works. So as a reference, you can use that fdisk or that cheat sheet down at the bottom. So in Ubuntu, since we have added that additional disk, we'll take a look at how all this works, assuming everything boots. Yay, there it goes. Okay, so crack open a terminal. Let's take a look. So before we were doing DFH, right? That just shows you the mounted stuff, but the thing that I just created that I added isn't mounted. So the way that we'll look at it is lsblk. And you can see SDB is new from the last time. It is 10 gigs, and it is a disk. So you could just straight up run makefs straight up on the disk. You can do that if you just want one partition. But For testing purposes and all that stuff, you need to go through the fdisk motions, so make sure you do so. So fdisk, well, you're dealing with things in the dev directory, so you're going to need root permission to do so. So sudo fdisk dev sdb. So you want to invoke fdisk, and you want to tell fdisk, hey, we're dealing with SDB. Oh. There we go. First thing you want to do, ask for help. There are a lot of options. And for you to remember all of them, it's going to take you a few times, right? So instead of trying to remember everything right off the bat, just ask for help. I mean, I do it every time. I think it's muscle memory now, just to remind myself and all that. But the first thing that you want to do is you want to create a new partition table. And you typically do that here. One of these options. GPT is the new hotness. It's been for the past few years, so we'll just do G. And this is just backing myself up, right? I said fdisk can deal with GPT. Well, obviously, here it is, G. Creating a new GUID partition table. Then, the next thing that we want to do is create ourselves a new partition. So, new. You can have 128 partitions in GPT. So it can be 1, 50, 100, 128, doesn't matter. But typically, partitions are created from the left to right, same as the way that we read. So started at 1. Next one will be 2. Next one will be 3. Next one will be 4. If you have this idea that you want to be creating partitions in between other partitions later on down the line or something like that, you can do odd numbers or something, 1, 3, 5, whatever, and come back around and add a 2 or a 4 later on down the line. However, messing around with partitions and sizes and resizing and things like that. So unless you plan on, creating that structure prior to actually using the space, then I guess that's how you would do that. But anyway, long story short, just start with 1 and count upward. If you hit enter, because it tells me here default 1. If you hit enter, it'll just be 1. Sector. So fdisk deals in sectors. And to be honest with you, so do disks. Typically, the reason that you start with 2048, the 2048th sector on the disk, is that the first 2047 sectors are withheld so that you can actually write the information about the GPT partition table there. So that is where GPT, the information about GPT lives. And then we start writing data to the 2048th sector and then move on up. So we have up to, what is that? 20,971,046 sectors. So unless you know what you're doing, you probably just want to keep 2048. So just hit enter here. And as long as you only want one partition, then you can do the last sector, which is the default here. Now, here's one of the cool things that you can do. You can also come in here and say, well, I don't know how many sectors 10 gigs would be or 5 gigs would be or whatever. So what you can do is plus 5G. And that'll be a 5 gig sector. Or it'll figure out how many sectors is in 5 gigs, and then it'll automatically add that in there for you. That way you don't have to try and do some kind of crazy math to figure out, where halfway is or something like that. So there's a 10 gig drive. If I wanted a partition that's about half, you would do 5, right? So plus 5G in this case. Or maybe you just want 500 megs, something like that, right? Whatever. But for me, I'm just going to do one big whole partition. That way we can deal with it like that. All right, and then it tells you, create a new partition, Linux file system, 10 gigs. To be honest with you, you can go in and look. I think it's L. Yeah, L lists known partition types. There's a bunch of partition types, right? There's EFI, MBR, Microsoft, NTFS, Linux, ARM, RAID, FreeBSD, Apple, Ceph, Solaris, NetBSD. There's all kinds of things, right? Linux doesn't care. If you tell it to mark it as ext4 or XFS or something, it's just going to do it. It doesn't care. it will deal with this in the way that Linux deals with everything, and that tends to be just brute force. So don't worry too much about it, but for the test, you're probably going to have to know right here. Linux file system, Linux swap. Those two are going to be the important ones. Since pretty much that's what everything is set to, and ours was set to 20. Linux file system. All right. So now, last thing we need to do, we've got this partition table. You can, let me see, P for print the partition table. So this will tell us what we just did, right? On disk dev SDB, which is 10 gigs, blah, 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 information. It's got a GPT partition layout. This is the disk identifier. It's got one partition right here. And it's set to Linux file system. If that's good with you, then you come out here. If that is not good with you, you want to do Q, quit without saving. But if it is, hit W. And it'll write that. And then you can do LSBLK again, and then you can see that it did work. It did create that partition for us. Now, so once we create a partition, we need to mark it as some type of partition. So we need to create a file system on that partition. You do that with makefs. Now, makefs used to be done like this, ext4 and then dev sdb1. However, that's since changed a little bit. You get rid of the T and you replace it with a dot after makefs, ext4. Sudo, obviously, you'll need to actually mark that. Runs through, writes all the information that you need, blah, blah, blah. You're good to go. So that works with any other file system as well. Make fs, say xfs, xfs, or butterfs. And you're like, but Leo, what kind of partitions can I make? Or what kind of file systems can I use on a partition? Well, make fs dot, and do yourself a couple tabs. And it'll list off all of the partitions that it knows about, or that it can deal with right now. Now, that doesn't mean that's all it can deal with. You can add in fuse modules and other things that will allow you to create different types of file systems or something like that, but at least for right now, the three that we're most concerned with, butterfs, ext4, and xfs, are all native. And that'll probably be the same across all three of the distributions. I didn't actually check, but I would imagine that it's probably the same. So we'll go check in here just a minute. So anyhow, sudo mkfs dot tab, and that'll tell you the different file system types that you can use, and then just finish it off, right? ext4 if that's what you want, or butterfs or xfs, fat, ntfs, whatever you want. You can do that. Now, since we've got this thing, dev sdb1, it is now marked as ext4, we can go on and mount it. So, sudo mount dev sdb1, and for now we'll just mount it in tmp. Let's do an lsblk. Look at that. Dev sdb1, blah, 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 information, mounted at /tmp. So if we go into tmp, we'll only find lost and found. We talked about lost and found a little bit. This is where files that have no owner go, or files that are corrupted go. We don't really deal with that. That's a root admin kind of thing. And to be honest with you, if it's in there, it's probably not worth it anyway. Anyway, so if you can, oops, that's two files. You create files in here, something like that, right? File named file and file named one. So you can use this any way you want. But here's the thing. When you mount something somewhere, it just becomes that thing. So if I mount SDB1 here, and then I create files in it, they are in SDB1. They don't stay in TMP once I umount. Watch this. Now remember, I can unmount this via dev SDB1, or TMP. Doesn't matter. Either the partition that you've mounted or the mount point. Ooh, it's busy. Oh, I think I know why. I think I'm in it. There we go. So we LSB OK, right? It's not mounted there anymore. Let's go back into TMP. Let's do LSL. There's a bunch of junk in it, right? My file and my number 1 are not in there anymore. That's really important for you to remember. So if we were to go in and say sudo mount dev sdb1, so that same partition, but let's mount it in media instead. If we go into media, what do you see? The same stuff. So the files follow around the partition. I mean, as you would expect, right? I mean, if you're formatting a flash drive and you put a bunch of files on it and you unplug it and you plug it into another machine, you mount it somewhere totally different, you expect those files to be there. That's how this works as well. So if we, oh yeah, let me back out, sudo umount media. And to be honest with you, the way that I decide which one to use, whether it's media or dev sdb1, is whatever's shorter to type. I'm lazy. And then we go back into media, and you can see nothing. But the big thing that I want you to understand is that no files are ever destroyed if you mount or unmount something. The only time files are destroyed is if you unmount something before files are done writing to it. Like, you know, if that progress bar is going across or whatever, and then you decide to unmount it, yeah, those files are borked. But, I mean, outside of that, the files are there, and they will remain there so long as the physical hardware is fine. So the reason I did that, or the reason I mounted it in temp, is because I wanted you to see, right? There's stuff there. So let's mount it back in TMP. Oh. Get out and get in so it'll update, right? So the stuff that was there is no longer there. Now the files that I'd created are now there again. Oh, I keep doing that. Unmount it, get into TMP again, and the files come back. Right? So the files are only ever masked. If you mount something on top of another thing that has stuff in it, those files are masked. They are invisible at that point. You can't get at those files until you unmount the volume that sits on top of it. To be honest with you, you should just be creating directories to mount stuff in, right? So I don't want it in temp. I want to create a, let's call it Leo's mounts, right? And then I can sudo mount dev sdb1 into temp Leo's mounts. And then I go into Leo's mounts and voila, they're my files again. Right? That way you're not masking any files or anything like that, and no one has to ask where files went or anything. Right? So create yourself directories to mount things inside of. That tends to be the easiest way. And a lot of times people will use media. All right? There's not a lot in there in the first place. So create media. And by default, Ubuntu will create a username for you here. So there'll be a Leo folder in here, and then a folder for each thing you're trying to mount. Anyway, those are the important bits. So now that you know, that's how you partition a disk. That's how you add a file system to a disk, and that's how you mount something to a disk. Those are the hardest things. Let's look at cat etc fs tab. Look at that one more time real quick. Cool, everything looks good. Right. So now we want to do something here. We want to actually mount something. So what we're going to say now is dev sdb1. I want dev sdb1 mounted at tmp Leo's mount. I'm going to have to double check that. I don't remember if I did a mount or mounts. It is ext4. I want the defaults. I don't want it to be, oh, here, I've been doing spaces. Let's do tabs. ext4 tab. Oh, did that wrong again. Root ext4 defaults. I do not want it backed up. I do not want FSCK dealing with this at all. Okay. Gonna write that. Oh, whoa. I messed up here. I do not need an extra mount point there. So I've got partition I want to mount, where I want to mount it, what type of file system it is, what options I want with it, defaults. Do I want it backed up? Do I want it checked? Those answers are no. So write that out. And let me double check. Oh, what is it? Leo's mounts. And that's what I did, right? Pretty sure. Leo's mounts. Okay, so this should work. should work. Everything looks good. All right, well, now or never. Let's reboot this guy. If I made a mistake, then it's going to drop me into recovery mode, and I'll have to fix it. I'll show you how to do that. If it doesn't, then you're good. Recovery mode is basically single user mode. It is where you are root, and you are just going to run commands like you normally would in this command line. So it should not be scary. It's the same exact thing that you've been dealing with, whatever. All you need to do is nano into etc fs tab again, and then fix your mistake, whatever that might be. Save it, reboot, and if it boots, you're good. If it doesn't, go fix it again. All right, so we're going to reboot this guy, and we're going to see how this goes. So far, so good. Hasn't yelled at me yet. Aha, I think we're okay. I did not typo. Hooray for me. Oh, figured it would show me. Guess not. Yeah, but it is mounted. You can go there. Temp Leo's mounts. I think, actually, I think it's because I didn't mount it in media. Typically, if you mount things in media, it'll show up here in this list. But I can get there. Go back. Or not. Go to other locations. Go to computer. Go to TMP. Go to Leo's mounts. And there are my files, right? One. Had a lock on it though, so I think the permissions might be broken on it. Yeah. Let's see, Leo's mounts. Oh yeah, root owns it, so I'll want to change the ownership of that to Leo. Yeah, I don't know. After I installed the GUI, it started popping up, so I'll have to look at that a little later. I want to do this recursively. Leo wants to own everything in here. Temp Leo's mounts. There we go. Now if I go back, Leo's mounts doesn't have that lock on it anymore. Now I can actually create some folders in it and stuff. Oops, that's right. I didn't want to do that with lost and found. I need to go fix that real quick. Root typically needs to own the lost and found thing, not Leo. So sudo change ownership, recursively root lost and found. There we go. That's better. There we go. And now lost and found doesn't show up anymore. That'll do it. And now I can create new stuff if I want. Good to go. All right. It gives you a basic idea. You may have to play with the permissions after you're done. That's the last little bit. All right, so now what we need to talk about is LVM and MDATM. So let's see which one's first. MDATM. All right, so MDATM. This is the multiple disk administration utility, MDADM. So multiple disk admin. This is the way that you're going to create software-based RAIDs in Linux. So there's absolutely a difference. You have a hardware-based RAID, or you have a hardware card that plugs into your PCI slot. You plug all your disks into it, and then the card handles it. You log into the card's BIOS. It is a secondary BIOS, and then you just create all your RAIDs there. And then whenever you boot into your system, if you created a RAID 10 out of 100 different disks, that would show up as just one disk to Linux or to Windows. So that is typically the way that RAIDs are set up. However, software RAIDs have become more and more popular because they cost less. You don't have to buy additional cards for them. And those cards are not cheap. The good ones are like $600. So if it breaks, that's 600 more bucks. Now, as far as software RAIDs go, those are free. As long as you can plug all the hard drives into your machine, they're free. So the deal with that is going to be that you need to use MDADM, or multiple disk administration to create these. And it's actually fairly simple to do. And once you create them, you just start dealing with these numbers. Now, Ubuntu only, I think, has a bug where you create MD0, but it errors out and throws you to MD127 or something like that. So be aware. You'll want to just pay attention to if that changes at all, if you're going to mount it. So I'll show you what I'm talking about. I'll create one. I'll reboot. We'll see what happens. I don't remember if I have you doing MDATM on Ubuntu or not. If it's not on Ubuntu, then you don't have to worry about it. But if it is, yep, sure enough. So we'll need to be careful with that. Okay. Oops. No, come back. All right. So let me kill Ubuntu. We'll add a couple more disks, and we'll do this thing. All right. So the way that this is basically going to work is all you're really going to do is identify the disks, use LSBLK to figure out what, dev SDC, dev SDD, dev SD this, dev SD that, whatever it is. Find out which disks you're trying to deal with. That is going to be the most important thing. Because if you don't know what disks you're dealing with, then you might end up blowing stuff up. I'm going to create a fourth one so we can play with LVM in a minute. Oh no, I never attached the third one, no. No, wait, that's it. Just choose it. Here, I think I want them in order. The order actually does matter. This is why we'll talk about UUID at the very, very end of this. Oh no. It'll be okay. So the reason that you care about this is that this will be dev SDB, SDC, SDD, SDE. So the order in which they are plugged into your SATA controller actually does matter. And this is why you want to use those IDs that we were looking at before to mount things instead of dev SDA, dev SDB. Because if I were to go in and swap 3 and 4, the letters would swap as well. This one would become ABCD, whatever is in this position is D, whatever in this position is E. So got to be careful with that, but it should be fine no matter what. So long story short, use UUID. So it's instead of doing like dev SDB1 in FS tab, you just do UUID equals and the UUID, and you can get that from BLK ID. You just copy and paste it. That way you don't make any typos. UUIDs are massive. So typing them out is probably not a really good idea. Cool. All right. So now we can look, LSBLK, right? C, D, and E now. And this is pretty much it. So mdatum, you're telling it to create, and you got to tell it to do something. It's always got to do something. If you do man mdatum, you can see man mdatum. You can see right here, right? There's assemble, there's build, there's create, there's follow monitor, there's grow, there's incremental assembly, there's manage, there's miscellaneous, there's auto detect. So it can do quite a few different things, but you have to tell it a mode every single time. And in our case, that mode is going to be to create. And you're telling it what to create. So you're going to say dev md0. Typically, all of your RAIDs will be md, multiple disk, 0. Start with 0. Dev md0. L1. So it's telling it what level, RAID level, and in this case, RAID 1, so 1. L1. And then in. Oh, actually, I think I got a typo there. You got to tell it how many disks. Number of disks. 2, and then dev sd, let's do C, and then dev sdd. So let's see if I have made a mistake. I don't think I have. Yep. So the array has metadata at the start and may not be suitable as a boot device. So basically what it's telling you is that you don't want to boot off of this thing, which is fine. I'm not planning on doing that anyway. Continue creating. Yep. All right, so now lsl dev md, and you can see dev md0. It's the only one in there, and it's a block device. So if we do lsblk, you can see that now SDC and SDD are both attached to MD, and this would work no matter how many disks you had. Every single one of those disks would be attached to MD0, and it'll even tell you what RAID level it is. That way, you never forget. LSBLK is very, very informative. And then whatever you want to do, right? At this point, you can treat MD0 the same as you do SDB1, SDB2, whatever. You can format it. So sudo mkfs .ext. Well, let's do xfs. Why not? xfs dev md0. Right? Good to go. Then you can mount dev md0 at any particular location that you want to. We'll mount it into temp, cd temp, lsl, nothing in temp, right? It's kind of the point. And that's it. So if you do an lsblk, you can see that all of that is there, right? If you had a question about how it would show it under mount point, it's like that. Every disk that's part of the multiple disk array is just going to also be mounted at the same exact spot. That way you kind of remember what's what. And then, yeah, that's the other big bit. It tells you what kind of RAID you're dealing with. All right. So, I mean, mdatum is actually pretty quick. That's all it really is. You pick your RAID level, you tell it how many disks, you give it the MD number that you want. Typically start at 0, work your way up, and then you give it a list of all the disks that you want involved in that particular array. That's all there is to it. And then treat it normally. After that, you just got to remember it's MD whatever number you gave it. Now, here's the thing that I was talking about before. Ubuntu has this weird issue with MD that after you reboot, it changes numbers. So what I would like you to do in the lab is go ahead and reboot it. After you create MD0 and you make it, you set it up however you want to. You can mount it to test it and all that kind of fun stuff to make sure everything's good. But reboot after you do that. Before you set it into etc fstab, because otherwise you're going to get dropped into recovery mode a bunch of times and you're not going to know why. So you pay special attention to this. Once it boots, we're going to take another look at LSBLK and see if it changed. It may not change on you, but there's a good chance. When I did it a while ago while I was reading or making this lab, ended up finding a bunch of bugs about it. So MD127 is probably what it's going to be. So let's see. Yeah, MD127. So now you're going to be able to do that. I didn't actually get the full explanation as to why it does that. But just be aware that that's the case. MD127. That's the deal. All right. So we should be able to now ldev md. Yeah, it's just dev md127. So that's fine. Does not bother anybody. And before we go, I'll go ahead and try to mount it, but let's just get this stuff done. Because we got about 20 minutes left. All right, so removable storage, I mean, it works exactly the same way as everything else, so you don't have to really worry too terribly much about it. Most flash drives or hard drives or anything like that, when you plug them in, they are they show up as regular disks, so SD, whatever the next letter is that you haven't been using. You create them, format them, or create partitions, format them, and put a file system on them the same way as you do everything else. There's really not a whole lot of things that you need to actually deal with in terms of USB devices that is different than any other disk. So just be aware, they look different. As far as, you know, you'd have to do LSUSB to see information about them. You will see them in LSBLK though, so it's really not that big of a deal. It's just here so that you know that USB devices are treated slightly differently, but as far as partitioning and everything else goes, they're the same as everything else. So we've been using DF a big bunch. You've seen what that does. DU is actually really cool in that it will tell you usage of a specific directory. It'll tell you, it'll tell you information about anything, right? So you can do home Leo, and it'll give you information about all of the stuff inside of there. The thing about this, though, is that it's in bytes. So a lot of times I will go in and throw in the H option, and that'll give you an idea, right? So if you're looking for you know, big files taking up lots of space on your hard drive or something like that, this is a really good way to do it. I think there is a order it, like from biggest to smallest. Summarize is also nice. Gives you just some the easy information so you can look at it kind of at a top down. Yeah, I'll have to dig in just a little bit. I don't want to waste a lot of time doing that, because since we're running out quickly. But yeah, so I know certainly there is a way to do that. So I'll come back with it. If you guys are curious about what that is, just let me know, and I'll make sure to figure it out for you. LSBLK, right? This is the same information. DF will show you information that comes from the sysblock directory. Come on, there we go. And you can take a look at that real quick. LS sysblock. There you go. You can see all the devices that are dealt with. You can see our MD127 in there. This is where DF actually pulls this information from. And the other one's proc partitions, right? Yeah. LSBLK, or yeah, LSBLK will pull information from the proc partitions file. Same basic information, right? Just so you know, those tools aren't magic or anything. They actually pull from other files. BLKID. This is what I was talking about before. If you're trying to mount via UUID instead of the actual physical partition number or something like that, you'll want to use BLKID. MD127, if I were trying to mount that, I would copy this UUID right here. Come on. I hate trackpads for really intricate things. Copy that out. Type XFS, just note that. Then you'll want to nano etc fs tab. Come down to the bottom. UUID equals. Paste that in there, and then do the rest of it the same. All right, so let's say you want that in TMP RAID 1. That directory doesn't exist, so you'd need to make this directory before you actually go and do this. XFS defaults 0, 0. And that $sign is telling you that there's more. So $signs on the left, there's more to the left. $signs on the right, there's more to the right. So use your arrow key to go back and forth. Either that or just make the window big. And that'll fix that. Right, so that should work as well. Okay. Dumpy2fs is basically going to give you information about ext file systems. You should see sudo dump e2fs on dev sdb1, and then you can see all the information about this thing. Lots and lots of stuff, right? This is getting down way into the nitty-gritty of any particular file system. If you do this on a drive that you are using as root, I think you'll get that bad super block. Yeah, bad magic number in super block. And it's because it's mounted as being currently used right now. You typically will want to do this in a recovery mode or something like that if you want information off of the system disk. Dev SDA2 works okay. Ooh, wow. That's a lot of info. So, anyway, just some tools that you need to know of. File system corruption happens a lot of times, especially if you interrupt things. Yep, or if you shut down the system wrong. Remember, I keep telling you guys to treat these computers the way that you would any other actual machine. You want to properly shut them down. If you do not shut them down correctly, you can end up with, it's not a guarantee or anything, but you can end up with file system corruption, which basically means that whatever file that you were working on or anything that was in memory may actually be broken next time you reboot. So that does include system files, which means there is a potential to just bork your whole system. And a lot of times what that ends up translating into is it's telling you it's not going to boot. You get a kernel panic on boot, or it just tells you can't find this file, can't find that file, something like that, right? There's this idea of syncing. So a lot of times when you move a file from one place to another, it doesn't actually get written onto that disk. Immediately, it ends up in RAM, and more higher priority things get dealt with first, and then that file gets written onto the disk. This is why you want to, with Linux and Mac, want to unmount the drives before you remove them from the system, pretty much every single time. If you unplug it, you'll end up with file system corruption. So you do not want to unplug things before ejecting them. Make sure you eject them. Bad blocks. This just happens. This is something that you cannot change. And while this is this talks specifically about magnetic charge, it's also talking about the electrical charge in SSDs as well. Over time, the magnetic charge will fade, as well as an electrical charge will fade, which means that, if it's magnetized or if it's electricized, what is the word for that? Electrified. I don't know. I'm sure there's a better word for it. It means a 1. If it is not, it is a 0. So sometimes those 1s will fade into 0s and corrupt your data. And there's really not a whole lot you can do with this, except for choose good file systems. LVM is a way to deal with this. And I think I skipped it, didn't I? Oh, I sure did. Look at that. LVM's up there. Whoops. I'll circle back. But anyway, magnetic charge, right? It'll go to 0 sometimes. So FSCK can detect these things. Sometimes it can fix these things, depending on whether or not parity is there. But LVM, which is the volume manager, and ZFS, which is a file system, can handle this. So there's parity in both of those things, and they can recover from simple bad block errors. So XFS file systems cannot use FSCK. They use XFS check and XFS repair. So this checks it for errors. This repairs the errors, or tries to anyway. FSCK, when you type it on any normal system, really actually invokes E2 FSCK. So E2, if you ever see E2 in the name, it's meant for ext file systems. Then there's also DOS FSCK and Riser FSCK if you're using either of those file systems. Butter FSCK for OpenSUSE, or ButterFS really. And Tune2FS is to change like labels and things like that if you're actually doing that. You can also do that with MakeFS. You can do that during makefs. All right, so I said really quickly that I was going to do with LVM, I was going to create a I guess a file system essentially using LVM on a single disk. So let's do that. The last one that we didn't use was SDE. So the first thing that you want to do is basically PV create. So there are three things in LVM that you need to know about. Number one, PV, physical volume. These are the actual disks. All you really do with PV create is say, I want this disk to be used with LVM. I want this disk to be used with LVM. So you can do PV create and then dev SDE, SDF, SD, on and on and on and on and on, and just mark all those disks as physical volumes. Now, VG create is a little harder to understand. VG is a volume group. And that's basically what you want to do with that is throw as many disks into that volume group as you want. So let's say you had 10 physical volumes, and you want 2 volume groups, 5 disks in each. So then you would just VG create and the list of the physical volumes that you wanted. And then you would do it again with the other set of physical volumes. I've got examples of this down here. So don't think I'm just throwing you to the wolves or whatever. Right? You want to VG create. You want to name the volume group itself. And then you want to specify which of the disks you're talking about. And then VG display will go on and actually show you if you created that correctly. I'll go in and format this right to differentiate the difference between commands and everything else. And then once you create a volume group, you can do logical volumes. So a volume group is basically just a grouping of a bunch of physical disks. It doesn't have any shape or form or anything like that yet. When you create logical volumes, that's where the form actually comes together. So let's say you have 10 disks at 10 disks at 10 gigs each. That's 100 gigs total. Put them all in the same volume group. And then you just go in and create a logical volume of 30 gigs. So LVM will handle all the heavy lifting and the thinking about all that for you. But just know that, each of those disks is 10 gigs, right? And you wanted a 30 gig volume. That means that there's probably at least 3 of those disks that are going to be used to create that logical volume. But the cool thing about that is that you don't ever have to think about it. Do not think about it. It is not worth it. You just need to know that you're creating a logical volume. You have a maximum capacity, if there's 10 disks at 10 gigs, your maximum capacity of 100 in that volume group, and you just want to create a 30 gig partition, which leaves 70 gigs for you to deal with later on. And you just create another 70 gig partition after that if you want to. Create a whole new volume group with fewer disks or more disks or however you want to deal with that, right? So you'll have to think about how you want your volume groups put together and how many logical volumes and how big they need to be. But outside of that, you don't really need to deal with much else. So in this case, we're just doing a really simple thing. We're adding one physical volume, we're creating one volume group, and we're creating one logical volume that spans the entire thing. So here's how we'll do that. So sudo pv create dev sde. Right? Physical volume successfully created. If you want to check on that, sudo pv display. And then it'll show you, hey, there's one. It's 10 gigs. It's on dev SDE. It's 10 gigs big, but it's not ready to be used yet. And that's because we haven't added it to a volume group yet. So then we want to sudo vg create. Now we need to name this, and you can see this on this command right here. You need to name it, whatever you want. We'll call it volley. Oh, here, let's just do it in lowercase. Name it volley, and then dev SDE. That's the physical volume that I want to be added to this volume group volley. Cool. And then you can check it, right? VG display. All you got to remember is physical volume, volume group, and logical volume. And if you remember that, just remember the VG. You can double tab, and it'll give you all the different things that you can do. And what I want in this case is VG display. Show me about this volume. Volley. It's using LVM2. You're able to do all kinds of cool stuff with it, like read and write to it, resize it if you want to. Here's how big it is. The more disks you add, the larger this will be. And if you do PV display again, it should tell you that what volume group it's a part of. So if you don't see VG name here, then it's not part of any volume group and you can add it to a volume group. Once you see that, though, it's part of a volume group and it can't be part of another volume group. One at a time. And then at this point, you just create a logical volume. So sudo lv create. And you want to create, you'll give it a label. Or I'm sorry, it's size. Right here. So let's see if I can remember how to do this. I think it's a little L, and I can do a %. Yeah. So if I do little L and like 100%, that should just do the entire size. But if you want like a size, you'll want to do a capital L. Yeah. L, and then how big you want it, and then the unit, so like meg, gig, whatever. But in my case, I want to do, all of it. So let's see if that'll work for me. Little L, 100%. It'll probably complain. I feel like I need a free in there or something like that. Anyway, so in my log vol, what was it? We'll call this one loggy. So, yeah, my volume was called volley. My logical volume is called loggy. And then you need to give it the volume group at the end. So in this case, volley. Yeah, I didn't like the %. I think you got to do it like that. Yeah, there it is. Okay, so 100% free. I knew it in my bones. I didn't remember, but I knew it in my bones. My bones were telling me that it wasn't right. So 100% free, 100% of the free space. And now we can do sudo lv display. And then you can see the logical volume size is 10 gigs. It is called loggy. It is part of the volley volume group. And physically, this is where it lives. So if I went into dev volley, I would find a logical volume file named loggy. So let's do that real quick. Volley. Inside of there is loggy. Right? And it's really just a link. It actually just dm0. But for our intents and purposes, we can deal with it as loggy, the name. So the cool thing with this, though, is that now all you got to do is just treat it like everything else, right? Same as we did with that MD0. Same as we did with SDB2 or whatever it was. I don't remember. We can just mark it as whatever we want. So sudo mkfs. Let's do butterfs this time. And we'll do dev volley loggy. Cool, right? Everything's good. Gave it a label. All that fun stuff. And then it tells you, there it is. Created one at 10 gigs, dev volley loggy. Right? And then we can, I think it gives you more information now. It doesn't. I thought it would. Meh, oh well. Okay, well, now that we know that that's the case, we can do lsblk, and you can actually see, though, right? Volley, part of the volley volume group. Loggy, the logical volume name is loggy. And then you can actually just mount this anywhere you want. Same as we have been before. So sudo mount dev volley loggy. So what do you want to mount? Dev volley loggy. And I want that to mount in mnt. So if I go into mnt, shouldn't be anything in there. lsblk. And then notice right there. There it is. Mounted at MNT. All right, guys. I totally know that this is a lot of information. The cool thing is, the things that you're really going to have to focus on are the dealing with the RAID, so dealing with mdatum, and dealing with LVM. LVM is probably one of the more difficult concepts to understand, and we didn't really go that far into it. I don't need us to go too terribly far. I just need you to know, like, the difference between a PV, a VG, and an LV, how they kind of interact together. And the rest of it is all the same. So once you have an LVM partition or a logical volume in LVM, or once you have an extent, a RAID array in MDatum, or you're just dealing with regular old disks, whatever that may be, at that point, once you have what you want, you use fdisk the same way, you use mounting the same way, you do makefs the same way. The only difference between any of that stuff is, where those things are, right? Dev SDA versus dev MD versus dev mapper a lot of times. In CentOS, that's how they're done. In dev mapper, in Ubuntu, they're done like this. Dev volley logi. Right, like that. But everything else is the same at that point, right? You just need to know where they are. And then you can format them. Same as everything else. All right. So again, I know it's a lot. So take your time. Ask questions. Do not just think I'm like, the situation is different right now, obviously, right? I mean, I'm working from home, but that doesn't mean that I'm not paying attention to the email and paying attention to Slack. Now, I got a little girl running around, so it does present sometimes a little bit of a problem, but I'll get back to you. Just ask. And, as long as you've got a little bit of confidence in yourself, I really would encourage you to ask these questions in the main channel in Slack, right? Go into the Linux channel in Slack and ask a question there. Because I promise you, this class is actually one of the biggest classes that I've got. Someone else has your same exact question. I promise you they do. They're just too afraid to ask it. So, you person that is listening to this right now, ask it. Trust me, I'm not going to be mad. I've been asked way simpler questions than whatever it is that you're going to ask. Yeah, not shameful at all. So please, just ask. Just ask. And if you can't do it, if you can't bring yourself to do it, send me a DM or send me an email. And then I'll ask you permission to relay that question to the rest of everybody else. Anonymously if you want, whatever. Doesn't matter to me. I just want everybody to get the information. I want everybody to understand this, especially in the situation that we're in, because it's going to be rough. I'm not going to lie to you. It's going to be a little rough. Being able to come in and talk to me face-to-face and stuff like that's a big help. I know that it is. And now that we are not able to do that, we're going to have to figure out some other way. I don't mind if we do WebEx, like WebEx connections or whatever. That way you can share me your screen, stuff like that. Or, in Slack, just send me screenshots. No big deal. All right. So I'll get off that soapbox. But, again, please just ask me questions. I will help. And then use the cheat sheet down here. I'll finish formatting it. I just wanted it in that Plex Mono font, or that Plex Serif font. So everything got blown up. But give me a little bit. I will finish editing that. It'll look a little bit better than that. And that will help you with the step-by-step of any particular thing. So as far as the lab goes, CentOS, you're basically just creating regular old storage. You're going to format it ext4. And I've got a couple of questions for you throughout this process, and then I want you to just do it auto-mounted. Regular old auto-mount, you can just use a partition name. Ubuntu, I want you to set up a RAID. This is really where I want you to pay attention. It may turn into that MD127, so be aware of that. Mount that. That may, if you mount MD0, it may break on you and throw you into the recovery mode, so be careful with that. But I want you to use the UUID. So make sure you're using block ID to identify that, and then you can copy and paste it into etc tab. And in OpenSUSE, you're pretty much just going to do what I did, whereas add a 10 gig disk, use LVM to create a physical volume, add it to a volume group, and then create one logical volume out of the whole thing. I want you to do Btrfs, which actually, oh man, turns out I pretty much did the whole thing for you. So that's all right. Just follow along and do that. Use lsblk and mount it automatically using the UUID. All right. And then I think I do have a text screenshot, blah, 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 but here they are. Take screenshot, add all those to a submission. Make it PDF For the love of God, make it PDF. Don't give me a docx. It breaks all the time. It's really hard to grade. It takes forever to load up. Don't give me a docx. Just don't do it. Don't do it. Really, just don't. Stop doing it. And actually, I think if I keep getting docx's, I'm just going to ban them from being uploaded. So if you take nothing away from this entire lab, take away this. Give me a PDF and not a docx. All right, I'll stop. Okay, if you guys have questions, please ask in Slack. From here on out, stay in touch. I will make sure you guys have any information, anything that changes or whatever. All right. You guys have a good rest of the week. We won't have anything on Thursday unless you guys request it. So outside of that, have a good week. We'll see you soon.